Yeah. So it says for number 2, determine the amount. So as soon as it says that, they're looking for N. Make sure you know that, right? Because that's what the questions are going to say. And then people come to me and say, what's the amount? And I'm like going to be like, well, you decide. Because I freeze up during quizzes and tests. So determine the amount of xenon tetrafluoride. So I think that's going to be an important part. Tetrafluoride, which looks a little something like that. And then that's it, right? So I guess, and we have, 22 grams, yes? So I'm going to put 22 grams in for the mass. I'm going to figure out the molar mass of that. Help me out here, somebody, anyone? How about Sydney? 207.29 grams per mole. Let's make sure we use units. I know I didn't for the other part, but let's make sure we do that. We're going to divide those two, and we should get apparently about 0.11, yes? Okay. Now, just a quick little note, because we're going to do this today here. So, and again, you don't know this, so that's fine, but we're going to learn as we go here kind of thing. So when I take 22 divided by 207.29, you get 0.106, yada, 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 right? Okay. 0.106, blah, 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 moles. Okay. And then for this part of the answer, we definitely want to have it. Basically, they're saying, okay, well, how many moles is that? Well, we know we have 2 significant digits in this question, right? Right here, 2 significant digits, because that's what was given to in the question. So, of course, you guys went 0.11 moles, yes? Okay. Good? Okay. Second part says this. How many moles of fluorine would there be How many moles of fluorine would there be then? That does not sound good. Who wrote this? Okay, so basically what they're saying is, look, if we had a mole of this, if we had 1 mole of that, 6.02 times 10 to the 3, how many moles of fluorine would be in that? Okay, basically they're saying, well, again, if we had 1 mole of that substance, how many fluorines would there be? There'd be 4 moles, okay? Because there's 4 fluorines for every 1 compound, basically. So that's all they're doing. They're just multiplying it by 4, okay, to get 0.44 moles, okay? I'm not too worried about that question because we're going to do that today, but differently, okay? So I'm not too concerned about that. All right? Any other questions there? Somebody? Yep. 3. Okay. Okay. Yeah, well, that's probably because we didn't convert properly, I'm going to assume. So we're talking about calcium chloride. So this is number 3. Let's see here. 20 kilograms of road salt, which is, of course, calcium chloride. What do we got to use here? How many moles? So basically another way to say that, so what's the amount, right? So again, mass and molar mass. We have 20 kilograms. So that goes back to our little chart, okay, that we're going to need to use here. Now, we just have to remember that we do need to be able to convert, of course. I'll probably give you the chart, I think, for a quiz or a test if we need to or whatever. But we have 20 kilograms. And remember, there is units to go with this, right? We cannot put 20 into here because that's kilograms, and this is going to be measured in grams per mole, yes? So kilograms and grams don't really match up. Now, there's a ways around that, but I'm not going to get into that right now, okay? We need to, at some point, you need to be able to do the conversion probably anyway. What is the molar mass of this? It's like 40, and that is, it's again 110.98, yeah. 110.98 is going to go here. That's the molar mass of this, right? 1 calcium, 2 chlorines. So that we're good there. That's, like I said, that's measured in grams per mole. So the top part has to be grams. Usually that's how it works. There's, again, if you understand the metric system and all that, there's ways around that, but we're not going to do that, okay? Or I'm not going to do that. So you have to change this into kilograms to grams, right? Kilograms is here. I don't know if you remember this, but there's a hectogram. I think it's a decagram, and then a gram, right? So if I want to get from kilograms to grams, I got to go 1, 2, 3 steps down. Okay, so that means I got to move the decimal 3 places to the right. Yes, because I'm going down the chart. So if you had a kilogram, of course, of something, that's 1,000 grams. Yes, that's another way you could do that. So right here, we should be putting 20,000 grams. Okay, and when we divide those two, let's see, I picked the right one here. We got 20,000 divided by 110.98, and we get 180.212. And of course, like I said before, the grams and grams would cancel, and we did the reciprocal thing yesterday, and we'd end up with moles. Significant digit-wise, you look back in the question, I would say we have what? Well, again, this is 3 significant digits. Now I know it's in kilograms, I get that, but again, if they wanted more significant digits, they would have said 20.0000 kilograms, right? So that's 3 significant digits, that's all I know. It doesn't matter what the units are, that's 3 numbers, they're significant numbers, so I can only have 3 here. So I'd probably say 180 moles would probably be my best answer. There's nothing wrong with that. If you wanted to make it in scientific notation, I guess you could. For a little review, 1.80 times 10 to the 2 moles would be an option as well. Okay, I don't know what the answer is. Yeah, I guess they gave it to that. But either one of those, fine. I'm perfectly fine with 180. I mean, I don't see the need to write down the scientific notation if you don't have to, kind of thing. Does that make sense? Okay, good. Okay, yeah. Xenon. Yep. Yep. Yeah, but if you look farther down, xenon at where you know what? I'm not going to talk about that. Yeah, come back next year. How's that? Come back next year. It can actually react because they become more radioactive down there. So there actually you can force them to react. There's so many electrons there that they will eventually share, if possible, if you wanted to. That has to do with something. No, I'm not going to get into it. Usually we just say they don't react. So. Oh yeah, it's way more likely to react than neon or argon or something like that. Yeah, absolutely. Yeah, and neon and argon wouldn't. They're very, very stable. But as you get going down, there's so many electrons that they will start. Just like radon is radioactive, right? So, okay. Any other questions? Yes, no? Yep. 6? Yep. Is 6, you said? I keep clicking on that. I don't know why. 6. All right. 3.57 moles of vanadium. Calculate the mass. So again, we have to be able to solve for this, yes? So we need to cross multiply or multiply both sides by big M, I guess, is probably where I'd start. Whatever you want to do, same thing. You're going to get the mass is equal to N times big M. N is the amount or the number of moles, which I have here, by the way. It's 3.57. And I'm going to put that into there. And then I need to figure out the molar mass of vanadium. And I have no idea what that is. Yep. 50.94, okay, grams per mole. And that just comes right from the periodic table, okay? And we just simply multiply those two numbers and we should get those there, 182-ish. Yeah, okay, good? Yep. Yeah. Yeah, I would like that probably. Yeah, I want to make sure that you guys are doing that. And I think we talked about this yesterday, right? If we did have to solve for, let's say we wanted to solve for big M, okay? Again, remember, there's 3 variables, right? We have to make sure that big M is on top, first of all. So I know sometimes we talk about, oh, well, I'll just move this to the bottom. So and this is not actually wrong. The problem is, you know, I get this a lot, so I don't know if I should even show you this, but people say, well, if I want to get big M by itself, I'm going to move this over to this side here, which in other words, if I'm going to take little m, I'm going to divide by m on both sides, which you can do. That'll get rid of that, and then that's there. But is big M on top? It's what you solve for is basically this, right? and I don't mean to confuse you, but that's what you solve for, right? So big M doesn't equal anything right now. 1 over M equals something, okay? So in this case here, we're kind of back to where we were before. You could always cross multiply, you know. I mean, that's not wrong. It's just that we haven't solved for big M. We've had 1 over at big M, right? So, you know, at some point, you know, if you cross multiply, you know, does that formula look familiar to you? Yeah, right? And then again, if we want big M by itself, you're still going to have to go divide by N, divide by N. Notice we end up with big M is mass over moles, which is what it is, grams per mole, right? Make sure the units make sense when they're all done, right? If you're multiplying these two here, for example, well, moles cancels out with grams per mole, and we're left with grams, right? So they should always make sense. Okay, good? Yeah. Okay, and people say, well, I'll just memorize those 3. Well, that's fine, but what are you going to do when it gets to be 5 variables someday, you know, or 6? Because it's going to happen. You're not going to memorize all of them, okay? And we have to be able to do that. That's what you're going to do this over and over again in high school. That's just a given, okay? I promise you. Okay, good. Any other questions? Okay, we're going to move on today first, and then I know we have a quiz that we want to go over and stuff, but we'll get to that in a sec here. Is this what I want? Yeah, it is. But I know this looks like a lot here, but don't worry about that. Let me pause this. I'm actually probably going to read off of here because this won't quite match up, but it's pretty close. We've already practiced converting between the number of particles and moles. So I remember 2 days ago we said, hey, if you got like 2 moles, how many molecules is that, right? And we did that little ratio, remember the egg thing, right? 1 mole is 6.02 times 10 to the 23 of anything kind of deal, okay? So we had that. That was 2 days ago. So we did that. We also talked about how do I convert mass into moles. That was yesterday. We just had the questions on that. We're now going to combine the 2 together. Okay, so we're going to do that. We can also convert between the number of particles and mass. Okay, hint, it's all about the moles, so make sure you put that in there. Just put moles. Okay, moles is the gateway. Moles, all about the moles. Okay. Now, we're going to fill this in, and I'm going to get you to write down one more thing here. But if you're looking, so if you're given the number of molecules, atoms, and are looking for the mass, find the number of moles, use a ratio. That's what you're going to put in there. Use a ratio. And then you're going to use that. Okay? So those are the first 2 blanks that you have to fill in there. Yeah. I'm going to give you a little different visual thing here too, and we're going to fill that in together, and that might help. You're not going to have a lot of room on, well, you might have enough room on this page. If not, there's a whole back side here that you can use. In the second 2 blanks there, it says if you're given the mass and are looking for the number of molecules or atoms, we're going to find the number of moles using this and then use the ratio. So you'll notice you're writing the same 2 things down, but you're just changing the order of them, okay? And I'm going to show you what that looks like right away here. Okay, so write those in the 2 last blanks there, or the 2 bottom blanks, and then we're going to get right into examples. Now, you don't have a ton of room here, so you probably do need another piece of paper, to be honest, okay, because I want this nice and neat, and we want to be able to follow kind of some steps here, okay? Now, before we get to that, I'm going to give you another option here. So listen, I'm going to go right here. If you, okay, we're going to kind of go in this order, and you can kind of go either direction here, or you might not have to go all the way. So if I give you the mass of a substance, okay, the key here is, you know, if you noticed, it's always about the moles. So if I give you the mass, the first thing we're going to do is change it to moles, okay, or amount. I'm going to put here moles, and I'll just put above it amount is the key word there, yes? Okay. If I have the number of moles, I then can find the number of molecules. And remember, there's different words that go here from 2 days ago, right? There was molecules. What's another one? Do you remember? Formula units would go here. Atoms would go here. Particles. All those things. No. Okay. So that would be the number of compounds, the number of ionic compounds, the number of atoms, the number of molecules, the number of particles that you have. All those things mean the same. Okay. Now, to get between these things, okay, so if I have the mass and I want to get to moles, how do I go from mass to moles? What do I use? I use a formula, yes? What's the formula? Tell me. Yep. So you're going to use this formula in some way, shape, or form, okay? Now, are you going to use exactly that formula? Well, yeah, if I want to get from mass to moles, mass, molar mass, that'll give me moles, yes? What if I was going from moles to mass? Do I use this formula? Yes, but I have to rearrange it, yes? Like we did, that's what we did yesterday, okay? How do I get from moles to molecules or vice versa? What do I use there? I use a what? A ratio. So I'm just going to put this down. Again, we might have to flip it over. We might have to manipulate it depending on the question, okay? So 1 mole, we know, is 6.02 times 10 to the 23 stuff. Okay, I'll put stuff. I don't know. What do you want me to put here? These things, whatever it is, right? Whatever you're doing. It might be an atom. It might be a molecule. It might be a formula unit. It might be a whatever, okay? Stuff, okay? Might be one of those things, depending on what we're trying to do here, what the question says, okay? So, again, we might start here, and we might go to moles, to molecules, right? Or we might start here and go to moles to mass, yes? We might start somewhere in the middle and only go do one thing. So this would be a review. If I started here and went to mass, that was yesterday's homework that we just went over. If I went from moles to molecules, and I started at moles and I went to molecules, that's 2 days ago, okay? So it just kind of depends. That's where you have to read the question and understand what you are given. That's why we write down, okay, this is N, this is little m, this is that, right? We have to understand that part. So when we look at the examples here, for example, okay, we're going to start going through this and say, okay, where am I on this chart here? Where am I starting? What do I need to get to? What are the steps kind of thing that I need to have? And by the way, I will give you this formula, of course, and you'll know this, but you're not gonna know this. So just practice is important here, yes? Okay, so as long as you know those two things and you know what you're starting with and where you need to end up, that's the key here, okay? So it says how many molecules of water, that's important, 1,000 grams. That's the mass, yes? Okay. Why is water important here? What can I figure out from water? Somebody else. The molar mass, right? So I can find out H2O here, and I can find out 18.02 grams per mole. Okay. So already I know that. Look, I know the mass. I know the molar mass already, don't I? So what can I find from those two things? N, right? Now that I know N, can I convert that to the number of molecules? By the way, now don't write this, pay attention. Is this the same as N? Is that N? Yes or no? Because this is the most common mistake, and people that struggle with this math stuff, they think that is N. Is this N? No. Okay. This is not N. This is that those two are, they're related, but N doesn't mean molecules. N means what? Moles, amount, exactly. Okay. So those are not the same. Okay. So we have to make sure we don't do that. Okay. Now again, where are you on this chart? You are starting here, aren't you? You're starting at the mass. We have the molar mass. We're going to convert it to moles, yes? So we're going to find N. How do we get to molecules here? Well, again, we're going to get this answer here. We're going to convert it using that ratio, yes? Does that make sense? Okay. So we're going to have two steps to do here. We're going to like I said, combine the last 2 days together here. So let's do that. We're going to start here. N equals little m over big M. Okay. N is going to be 1,000 grams divided by 18.02 grams per mole. And N is going to work out to be, calculator time, tater tots, 1,000. Again, make sure you're putting the numbers in the right spot. Please don't flip these numbers over. That's going to give a way different answer. We're going to divide those two. It's about 55 moles. That's a lot, obviously, but that's what it is, okay? 55.49 moles. Now, here's the important part here as well. So we're going to write down here 55.49 blah, blah, blah moles, okay? Is that my final answer, I guess? Did I answer the question yet? No. That's moles, and I need to get to molecules, okay? Now, we are not going to round this number because this is not my final answer, right? Okay, so I'm going to leave that number on my calculator. It's still there. And now I'm going to take this number here, 55.49 moles, and I'm going to be like, okay, I need to use a ratio now to get to molecules, yes? Okay, we are now here, right? We have now figured this out, 55.49. How do I get to molecules? Well, I'm going to use this ratio of moles and molecules in this case, yes? So here I go, 55.49 moles, and I'm going to multiply it by, okay? Now, where do you want to put the 1 mole? That's the easy part here. Let's worry about that first. Top or bottom? Bottom, yes? Because we want, again, 1 mole, watch, moles to cancel, yes? That means the 6.02 has to go on the top. So 6.02 times 10 to the 23. And again, in this case, we put down molecules because that's what we want to know, apparently, how many molecules. Okay? We're just combining those two things together. Okay? We multiply those two numbers. Look, this number is still in my calculator. It's right here. Okay? Right there. In fact, I don't know if you know this, but you can just go times. It takes the answer from before. You don't have to write it out again. It's unrounded. That's good. We're not going to round because this is not my answer. And then you can do your 6.02. We talked about times 10 to the 23 if you want, or you can also do E23. Okay? And like I said, you might want to write that down so you kind of remember that, but enter, and we're going to get this really big number here. Okay? Do not forget. Look, if you take 55 times 602 sextillion, you shouldn't get 3.34, right? That doesn't make sense. Like 602 with 21 zeros, and you times it by 55, you get 3? We probably should get a really big number, like 3.34. Actually, how many significant digits should I probably have in this question? 4. So we're going to go to 3.3407, so 3.341, yes? Okay, so 3.341, 4 significant digits, times 10, okay? And when you write this answer, I don't want you to write E, okay? That's calculator talk. That's fine for the calculator, but that's not how we write scientific notation. Times 10 to the 25, E25, times 10 to the 25 molecules, okay? And that would be your final answer. Again, we want to circle that or something, okay? These next examples are going to be all very similar, of course, okay? So just keep that in mind. That's kind of what we're looking at, kind of the pattern that we're looking at, okay? Good? Any questions before we move on? Yes, no? Okay. Well, let's take a look at another one here. Why don't you go ahead and start the first part at least? So kind of write down, obviously, again, let's start with some givens here, yes? How many atoms are in a 55-gram sample? That's important. That's the mass, right? Grams is our mass of iron. And again, what can we find from that? Well, we can find the what? Molar mass, yes? Good. Iron is, I want to say 55.85. Okay. I'm going to stop there for a real quick sec, but you guys go. Okay. That's really messy there, but we're going to take our 55 and divide it by the molar mass to get N. Again, if we're looking back at this chart here, we are here, 55 grams. We need to get to moles, right, here, which we just did. Okay, divided by the molar mass, that'll give us moles. That works out to be, what did I say? That's a 0.9847 there, by the way. Okay, it's pretty messy, but 0.9847, yada, yada, yada. Okay, we're not going to round. We don't round till the final answer. Okay, now I'm going to take that again and say, okay, well, that's great. I have 0.9847, blah, 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 moles, and I want to change it into atoms. How many atoms? So again, you have to decide, and this is usually what I would say. Start right here and say, okay, I have moles. I need to get rid of moles, yes, because I want those units to cancel, and I need to end up with atoms. So moles has to cancel with, in this case, a mole, right? So that has to go there. That's how you're going to determine what goes on the bottom, what goes on the top. I'd probably start there, even when we do the other examples, because those two have to match up so they cancel each other out. Okay, that's how it works. And then, of course, we're going to be left with 6.02 times 10 to the 23. In this case, we're talking about atoms because it's iron atoms, okay? We multiply those two numbers together, and that should be our answer, yes? And again, you're going to find that these are pretty similar questions here, of course. E23. E23 means times 10, of course, and we're going to get, what, 2 significant digits in this one probably, yes? So 5.9 times 10 to the 23 would be my final answer here. 5.9 times 10 to the 23 atoms. Okay, good. All right. Questions, anyone? Okay. And lastly here, you guys go ahead and do this one. The answer is right there, so I believe that answer is right. It should be, of course, 10 to the 23. But go ahead and give that one a try and see if you can get that answer there. This one is sodium chloride, okay? Remember, it's super important that we get the right formulas here, because if we get the right formula or the wrong formula, that's going to make the difference here. That's what's going to determine whether this is right or wrong. And again, you can kind of extend that over if you want. I mean, that's ultimately what you're doing, right? You're taking, I mean, you don't have to write this out again kind of thing. That's going to cancel with that. And now we're changing moles into formula units, yeah? Okay. Again, we have to get the right molar mass, 58.44, I think, for that. And well, that'll give us moles. And then we multiplied by the ratio, 1 mole is 6.02. And we're talking about formula units just because it's not a compound. That's the only reason, okay? It's no different if we were talking about atoms or molecules or whatever kind of thing. Good? Yeah, they'll tell you that usually. Yeah. Okay. All right. Now, what happens if we wanted to do the opposite? So, quite often here, we're going to work backwards as well. You're going to find that whatever we do one way, we probably should be able to do backwards as well. So now, okay, when we got molecules to mass, if you remember this here, now what we're doing is we're going from molecules to moles. Okay, just look up here for a second. Molecules to moles, or atoms to moles, or formula units to moles, or whatever to moles, and then moles to mass, yes? So we're just gonna work backwards. That's all we're doing here, okay? Same formulas, same ratio, just working backwards, okay? Now, the important thing here, though, is this, okay? There is no way to go from here, molecules, to mass. That is impossible unless you make a pit stop at the moles, yeah? You gotta go through the moles. The moles is the key here, okay? So you always have to do that. If you're going from molecules to mass, you have to find moles, okay? All right, so going back to here, here's our example here, which I think you guys already have. Of course, this is 10 to the 23 here. Atoms of copper, okay? So, and it says, what is the mass? That is what we're looking for, of course. And this number here, okay, is going to be my atoms, molecules, formula units. Look, it's super duper big, right? So that's kind of like, that'd be like our final answer in the last question. And then copper, of course, I know is 63.55 grams per mole. Yes? Okay. So the first thing I have to do is I need to convert atoms or molecules or formula units are pretty useless to me. Because that's a lot of that stuff. I needed to get it into a more realistic number. I need to get it into moles, okay? So the first thing I'm gonna do is, again, I'm far over here on the right-hand side. I wanna convert it back to moles in the middle, then to mass. So to convert it to moles, this was 2 days ago, we did this. Times ratio, right? We are going backwards now, so we got to get, if we're going between moles and molecules, this part, we have to use this ratio, right? What do I want to put on the bottom? The 1 mole or the 6.02 number with whatever units we're trying to cancel? Yeah. So we want, in this case, to put the 6.02 times 10 to the 23 atoms down here. The other option is you have a mole, okay? So you have to just pick, like, hey, look, where do I put the 1 mole? Where am I going to put this big number of atoms, or molecules or formula units? We need the atoms. If you put the mole down here, atoms and moles don't cancel, right? So we got to put the atoms down there. Now remember, when you go to do this, we talked about this last day, you have to be careful because you have to enter this appropriately into your calculator. And there was a couple options I gave you, but that's why I kind of like the E function here, because we got what? 3.01 E, which means times 10, 23, divided by, okay, 6.02 E times 10 to the 23, okay? You do not need to use brackets if you do it this way. If you don't do it this way, you better use some brackets. Because remember we talked about E46, E47, E48 stuff? Impossible, okay? Or as Homer Simpson would say, impossible, okay? Not gonna happen. So if you do this, that's fine. We get 0.5, because that's what it is, okay? So that gives me, right here, 0.5 moles. Now we're going to write that down, but remember, obviously that number is probably not going to be 0.5 in most cases. It's going to be an unrounded number. It's going to go on for a while. We need to find, now that we have moles, this is N, right? That's N. We have the molar mass. That's big M. We need to find little m, yes? So we use our little formula here. Now we're in the middle, and we're trying to do this. We're going to rearrange this so that we solve for little m. Cross multiply, yes? or multiply both sides by big M if you want. Okay, that was yesterday's homework, yes. Okay, and we just stick the numbers in. Look, we have 0.5 moles. We have a molar mass, which I said was 63.55 grams per mole. And when we multiply those two together, we should get about 36 point, no, I don't know. I'll do it on the calculator here. I'm not going to try to pretend that I know what I'm doing. 31, well, not even close. 31.775, okay? And again, we're going to use some significant digits, yes? Okay, so how many do I have in the question again? 3, yes? These ones right here, 3.01, 3, yes? So we want to have 3 in my answer, and again, 31.8 would probably be a great answer for this. Okay? Again, all you're really doing is you're converting units. You're changing it. You know, before we changed, you know, MT asked about the kilograms question, right? Kilograms to grams, we multiplied by 1,000, right? That's a ratio kind of thing. That's what we're doing here. We're changing 31.8 grams into half a mole into 3.01 times 10 to the 23 atoms, or vice versa, 3.01 times 10 to the 23 atoms into half a mole into 31.8 grams. They all mean exactly the same thing in this case, but they're just different units, right? Instead of talking about the mass, we go to what's the amount, okay? How, and then when we talk about amount, we talk about how many actually are on the scale. If I took 31.8 grams of copper, put it on the scale, how many atoms would be there? The answer is, well, 3.01 times 10 to the 23, because it's a half of a mole, okay? Next, you guys have this here. You guys go ahead and start finding there some answers, and we'll kind of speed this up here a bit. I'm going to be quiet. You guys go ahead and start that. This is the same one you guys have, right? Yeah. Okay. Okay. Oops. Okay. Did you guys get 153.81 for the molar mass there? Is that right? Okay. So we should end up with about 1.39 grams, yes? Okay. Is that okay? Questions, anyone? I didn't give you really time to do that, but I thought you were working and I'll work and see if we get the same spot here. I just wanted to mention this. I don't know, I just kind of screwed up. I didn't screw up, but I kind of wrote if you notice, I wrote the scientific notation like this time, 5.45 times 10 to the 21. But if you're going to do that, you have to divide by in brackets, right? So I forgot to use the E thing, but then I was too lazy to go back. But as soon as you do that, you've got to use brackets, okay? Have to, because now the order of operation, the calculator doesn't know, okay? When you use the E's, the calculator knows, oh, this number goes together, and I'm going to divide it by this number goes together. That's what the E does for you. So it takes that into account. If you don't use the E's, the calculator doesn't know order of operation, okay? Does that make sense? Questions, anyone? Ask. I see some puzzled looks, so ask. Chris? You're good? Yeah, I thought it was 3.8, but I rounded like 0.1. Oh yeah, you can. Yeah, you got to leave it there. Yeah, there's one more here real quick. That one there, yes. So I guess we have to have what? 10 to the 4. Yeah, something like that. And I'll let you guys work on that one. Same deal. We'll work on that and we'll see how that goes, and then we'll go from there. I'll just record the answer there. But any questions? Questions, anyone? No. It's fun to say, and therefore it's fun to do. Now, real quick here before you get to your homework. Good? Are we good? Question? I'll come around if you got questions here, but listen. Now, you're going to get some questions. I think you're going to get these questions today. We're not doing this all the time. So you have to read the question, decide where you are, and then where do you need to go? Sometimes we might be starting here. Okay, I'm going to mark this up a little bit more here, but you might be starting here, and they might just want this. Okay, that has nothing to do with this stuff over here then, right? So if they say, hey, you got 2.45 moles of magnesium nitrate, how many formula units is that? That's just that, right? You have to know where you are and which way you need to go to get there, right? You might be here, and they just ask you for the moles, the amount. That's it. That was yesterday. They might be here and ask you to go to here, and that's it. So don't just do the 3 steps because that's what we did today. I mean, yeah, you're going to get some questions like that, absolutely, because you need to practice them. We also have to understand, hey, we're not always going to ask those questions, right? You might just get something in between here. So we have to know where we are and where we need to get to, okay? All right.